Hello, everyone. What's up? We are back into a new video. This is new video. We said we are going to do a lab view playlist. Now this is the Matlab playlist. Our lab view playlist is on the channel. You can go and check it out. So this is our experiment number 5. We have been through experiment number 1, 2, 3, 4. Okay, the last time we did it was traffic signal. We are starting with MATLAB. As said, this is the experiment number 5. This is the step response analysis using MATLAB functions. So there are certain types of responses. One of them are step responses. These are certain types of step responses. Okay, so we will go through them one by one. Okay, so first we see the aim, we see the software needed, and we see the core concept what is there. So our aim is to perform a step response analysis of feedback control system using MATLAB functions. Okay, so how this will work is, um, so this is we are in a software MATLAB. The core concept this experiment teaches three most important MATLAB functions for control system: TF, feedback, and step. We will explain part A, the step response of unity feedback system. Okay, so the key procedure is goes like this. Okay, so this is our first, that is step response for unity feedback system. Okay, so first we define our open loop transfer function. GS is equals to 1 by s square plus s. To do this, we create a variable num1. Okay, so variable num1, we create another variable denominator. Okay, so num is the numerator, then is the denominator. This is our denominator we are going through, and this is a vector of a denominator coefficient as said. Okay, so this is our then we are comes our transfer function. This is a transfer function num comma then, and that is a feedback, the feedback we are getting. Okay, so we need to tell the system what are the feedbacks we want from it. Okay, we create okay, so next we use the transfer function. We write y is equals to tf num comma then. This creates a continuous transfer function g of s and stores in a variable y. Now we need to create the closed loop system. We use the feedback functions. We write m is equals to feedback y comma 1. This takes a function y, which is g of s, and puts it in a loop with unity feedback. That's what the one is for. Finally, to use to see the results, we write step m. This command plots the step response for a closed system and showing us the graph how the system works in response time. Okay, so this is our TS that I can show you. This is our TS. Then we have a num. Then we have a denominator. Num is the numerator. Then is the denominator. G is continuous time transfer function. That is your transfer function, of course. Then this is a discrete time transfer function. Then MZ is the closed loop system of the unity feedback. Okay, so here there is certain type of code. I will not go in depth with the code. It is easy to understand that we have a transfer function, we have a transfer function, we have a denominator, we have a numerator, and we have our g, which is the tf numerator comma denominator. This is everything we need to know. Then adding everything, we add dc gain. Dc gain g. The dc gain is a discrete time system. Okay, and the next photo we should go to is this. Okay, so this is our transfer function. Again, we move with the same levels, the transfer function, the numerator, the denominator, and then here we are not giving g, we are giving y. You can anyhow those are the variables, you can give anyhow you want. Then comes our feedback m, and yd convert the continuous time transfer function to discrete time. Okay, so till now there were many things, okay, going in this way. This is the last, this is the kind of finale. Okay, so it has everything we were doing till now. From we go from here to here, then to here, and then to here. This is the final one. Okay, so this is our peak time. We can show that time. This is a peak time. There are certain kind of things like settling time, peak time, which falls under time domain analysis. Okay, but we are looking at step response, so let's not go into that depth. So then we yeah, M1 feedback YD comma 1. Okay, so define the y2 is equals to transfer function numerator comma denominator input delay that is our delay, that is 0.5. So define the continuous time transfer function term with input delay. Okay, approximate the delay using a paid approximation of column, sorry, of order 2. Okay, so y3 is our pay, paid. Okay, so that is y2 comma 2, and 2 is another feedback which needs for every loop. Yeah, and that's all. This is our title. This is all the basic things. We are going from 0 till 1 till 1.5. 1.5, everyone has its level. 1.5, then 1.1 maybe, and then 1.4 is 1. Like this we have three systems, and as you can see the endings of it, they are very close to each other at certain point. One is in the one is below one and others are above one, but they are not above two and also under one. Okay, and then after certain time everything gets at a constant level. All these step responses are constant after a certain point for us, that is after 22 seconds. That is after 22 seconds everything gets constant. And that's all for this video. We will be coming back with another video. Another Matlab video is there, and then we will go to virtual lab soon. Okay, so this is the starting of the playlist for Matlab. Thank you for being with me. Thank you. Bye bye.